the roof off, we gonna get the roof off the motherfucker. Get the roof off the sucker. Get the roof off, we gonna get the roof off the motherfucker. Get the roof off the sucker.
You got a real type of thing going down, getting down. There's a whole lot of rhythm going round. You got a real type of thing going down.
Okay, section 2.7 is on implicit differentiation. So far we've been working with functions where one variable, usually y, is defined explicitly in terms of another, usually x. So for example, this one, y equals x cubed minus 2x plus 7. You know exactly what y is in terms of x. It's all this in terms of x, right? Same with this one, y equals the square root of 5x minus 3. Another way of thinking of it is you have the y isolated, and then the function itself has x's in it. Here's another one, y equals 3 minus x squared, all divided by x minus 2, all cubed. So again, you explicitly know what y equals in terms of x. Now, in all these cases, you can input a value into x to quickly get y. Right? If I wanted to know what y is when x is 2, I just plug 2 in here, 2 cubed minus 2 times 2 plus 7, boom, I've got my y. This one, 5 times 2 minus 3, take the square root, y. Right? Very, very quickly, very quick you can do that. In other functions, y is defined implicitly by a relationship between x and y. So for example, x squared plus y squared equals 25. We haven't isolated the y here. Now you might be saying, well, I could isolate the y here. All right, let's do that. Let's isolate y. So we're going to move the x squared over. We're going to have y squared equals 25 minus x squared. And then we're going to take the square root of both sides. But remember, when we're solving equations like this, you're going to have to put plus minus the square root of 25 minus x squared. And you actually could differentiate this. It's a bit of a drag though, because you're going to have to do it twice. You're going to have to do it once for the plus and once for the minus. So let's start with the plus. You'd have the square root, or plus if you want the square root, of 25 minus x squared. And when you're differentiating, you'd probably think of that as 25 minus x squared, all raised to the 1/2 power. What are you going to do next? You're going to use the rule we learned last time. You're going to use the chain rule, right? Our outer function is something to the 1/2. Our inner function is 25 minus x squared. So to get the derivative, you're going to bring the 1/2 down. You're going to keep the inside function the same. And you're going to raise it, use the power law here. The 1/2 changes to negative 1/2. Then you have to multiply that by the derivative of the inside here. What's the derivative of 25 minus x squared? Well, this is a constant, so you don't have to worry about that. It's just the 2 comes down, you get negative 2x. So if we solve that, you would have, you've got this 2 here on the bottom and a 2 here on the top, so those cancel. You're going to have negative 1x, or just negative x, over, this is a flipping negative, so this all moves to the bottom, and it's to the 1/2, which means square root. So this is if it's plus. What if we're doing the negative one? Maybe I'll do it way over here, sorry. I would have y equals negative the square root, just copying this down, right? The negative 25 minus x squared, which is the same as negative 25 minus x squared to the 1/2. Then to get the derivative, do the same thing. You're going to use the chain rule, so the 1/2 comes down. You get negative 1/2 times 25 minus x squared to the, this drops by 1, so it goes down to negative 1/2. Multiplied by the derivative of the inside, you again get negative 2x. So just like before, the 2 and the 2 cancel. This time what's different though is you get negative 1 times negative x. Negative times negative is positive. You just get x over the square root of 25 minus x squared. Okay, in both situations though, we could actually simplify it even more, because look at this bottom part. Look at the square root of 25 minus x squared. Do you see it's exactly the same as what we had here? Square root of 25 minus x squared, square root of 25 minus x squared, and we said it was equal to y. So what we can actually do here is we can say that it's equal to negative x over y. This is what we get. Okay, so similarly here, we have the square root of 25 minus x squared. Now, if you compare that to here, it's not exactly the same because we have negative square root of 25 minus x squared. So we can't say that this equals x over y, but you could say it equals x over negative y, right? So you actually end up getting exactly the same thing, negative x over y. So whichever way you do it, this is what the derivative seems to equal. So implicit differentiation allows you to find the derivative when the equation in question cannot be solved for y, or when it's really, really difficult to solve for y. You can use implicit differentiation at other times as well, like when you can find y, but it just doesn't make sense. It's a little more complicated. So you'd only normally use it when you can't isolate the y. And it's actually a special case of the chain rule that we talked about last day, so I'll try to explain that in a second. So here's the steps for implicit differentiation. First step is to differentiate both sides with respect to x. When you differentiate a y term though, you're going to multiply by dy dx, or y prime. You're going to have to include that when you're taking the derivative. And then the second step is you solve for dy dx, or y prime, if that's what you've written here. Okay, so there's the steps. Write it down. I know it doesn't make much sense yet. We'll go through a couple examples and I'll explain it as we do the examples. Okay, it says find the equation of the tangent line to the circle x squared plus y squared equals 25 at the point negative 4, 3. So if we want to get the equation of the tangent line, what we need to do is we need to get the slope. And you know the way to get the slope of the tangent line is to take the derivative. Now, one way you could do this is you could isolate the y like we did previously, but it gets a little complicated. We saw that already. So we're going to use implicit differentiation. Basically what we're going to do, step one, is we're going to take the derivative of both sides in terms of x. So I'm going to put d dx of the left-hand side, and I'm going to do d dx, take the derivative in terms of x, of the right-hand side. The sum law, I know this is really probably unnecessary, but the sum rule told us that when we're taking the derivative of a sum, we can also just take the derivative of each one of the terms. So basically that's what we're going to do, right? We're going to take the derivative of each one of our terms here. So let's start by taking the derivative of x squared. Remember, we're taking it in terms of x, so this is no problem. The derivative of x squared, if we just use the power rule, is 2x. Now, this is a little more difficult because this is the implicit differentiation right here. We're trying to take the derivative of y squared, but we're doing it in terms of x, and there's no x's here. So this is why it's kind of like the chain rule. You have to think here that your outside function is something squared. Now I know you're saying, well, it's y squared. I know, but we're doing this in terms of x, right? So we have something squared. Your inner function is y, and you want to think of it, it's like y is a function that contains x's. Like, I don't know, I don't want to solve for y here, but if I did, I could get a function in terms of x's, like y equals something x divided by this, square root, whatever, with a bunch of x's. So I don't know what that inner function is exactly, but I know that it involves x's. Let's think of it that way. So our outer function is something squared, our inner function is kind of unknown. So the chain rule will tell us that the first thing you do is you take the outer function, the something squared, and you do the power rule there. So the 2 would come down, it would become 2y, because you don't touch the inner function, and then that 2 drops down to just a 1. Now you have to multiply that by the derivative of the inner function. Well, the other inner function is just y, right? So we have to take the derivative of y. So how to do that? Well, you either write y prime, or if you want, instead of writing y prime, you can write dy dx. It means exactly the same thing. It's up to you. I'll do dy dx in this one and y prime in the next one, I guess. Okay, that's your implicit differentiation right there. Okay, the next thing you have to do is you have to take the derivative of 25. Well, it's just a constant. The derivative of any constant is just 0. Great. The second step and final step of implicit differentiation was to isolate the dy dx. So that's not too hard. We're going to move the 2x over. So we have 2y times dy dx is equal to, when that 2x comes over, it becomes negative 2x. We're going to divide both sides by 2y, so we get dy dx equals negative 2x over 2y. And you can cancel out the 2's here, and you will get your answer that dy dx equals negative x over y. And if you compare that to what we had before, you'll see it's exactly the same, negative x over y, negative x over y. So we got the same answer, but I would suggest that this was a little bit easier. It looks like a lot of steps here. Most of these steps you wouldn't even do, as you'll see in the next time we answer this. All right, so we now know, like we found the derivative, we've done it implicitly, but we found the derivative, which means that the slope is equal to negative x over y. Well, we have an x and a y value right here. Negative 4 and 3 are x and y value. So that means our slope's equal to negative 4 over 3, which is 4 over 3. We've got to get the equation of the tangent line. To get the equation of the tangent line, you need a slope, which we have right here, and you need a point. And we already have the point. The point's given to us right here. So we have everything we need. Now we can use our point slope form. So we will say that y minus y1, that's 3, equals m, 4 over 3, x minus 4, which means x plus 4. Okay, I like getting rid of the denominators right away by multiply everything by 3. So I'm going to multiply this by 3, 3y. I'm going to multiply this by 3, 9. I'm going to multiply this by 3, which cancels this out. So now when I expand, I only have to expand by the 4. So I get 4x plus 16. You don't have to do it that way. You can expand first with the whole fraction, but I prefer this way. So now, to get to general form, I have to get everything to one side and keep my x's positive. So I'm going to move everything to the right. I get 4x minus 3y. This minus 9 comes over and becomes plus 9. 16 plus 9 is plus 25 equals 0, but I'll write it on this side. And there's my equation of the tangent line. Okay, so here's one more. We're just going to find the derivative this time. We don't have to worry about tangent lines and equations and stuff. And so again, one way you could think of doing this at first is if I want to get the derivative of y, I should isolate y. But that's really, really difficult here. So instead of doing that, let's use implicit differentiation. How do we do that? Basically, you're going to take the derivative of each term, right? Because the sum rules tells us that we can just take the derivative of each term. So let's do that. Let's take the derivative of this one in terms of x. Easy. Power rule, 5 comes down, you get 10x to the 4th. Okay, now let's take the derivative of this. This is more difficult because you actually have two terms here. You have x to the 4th and you have y. You know what you're going to have to do here? Even though it looks like you can do it really fast, you can't. You know what rule you have to use? You need to use the product rule. It's not written very well, but that says product rule. So let's go ahead and do that. So product rule says, the way I do it, first of all I take the derivative of the first term, which is x to the 4th. No problem. Power rule tells us that would be 4x cubed, and I would multiply that by the second term, which is y. Plus, now I do the opposite. I write the first one, the x to the 4th, and I multiply it by the derivative of the second one. What's the derivative of y in terms of x? So the derivative of y, if it's just y to the 1, well, power rule says that 1 comes down, and then it's now y to the 0, so you don't even have to write it. But because this is implicit differentiation and we've just done a derivative with a y in it, we have to write y prime, or dy dx. Next term. Okay, outer function is the y to the 5th, so power rule, just like we did here, the 5 comes down, now it goes to a 4. But now we have to take the inner function, the y. Well, the derivative of the inner function is y prime, just like we did over here. And we take the derivative, everyone always forgets to do this, don't forget, we have to take the derivative of this side. So what's the derivative of 36? Derivative of 36 is 0. Okay, next step, you got to get the y primes by itself. So you have two terms with y primes. Why don't we leave those on this side? So we're going to have x to the 4th and 1y prime, which is just y prime, plus 5y to the 4th y prime equals, let's move these two over to the other side. So we'll have negative 10x to the 4th when it moves to the other side, and negative 4x cubed y. Now we have to isolate the y prime. So why don't we factor out a y prime from these two terms? We'll have y prime x to the 4th plus 5y to the 4th equals everything on this side. Notice you can also, if you want, factor out the negative. I don't know, you could have done it when you moved it over. You could do it now. You could factor out more than just a negative. You could factor out a negative, 2x cubed. You want to do that? Why not? And what would we be left with? We'd be left with 5x and plus 2y. Okay? Now the last thing we want to do to get this y prime by itself, since this y prime is multiplying all this, you're going to divide both sides by that. So when you divide this side by x to the fourth plus 5y fourth, they'll cancel. You're just left with y prime. When you divide that side, well, you're just going to have the same thing, negative 2x cubed, 5x plus 2y, all divided by this, x to the fourth plus 5y to the fourth. And you are done. This is implicit differentiation. It would be so hard, if not impossible, to find the derivative of this by isolating y, but if you get this implicit differentiation idea, it's quite quick. So the main thing is, when you take the derivative of y, if you're doing the derivative in terms of x, but you encounter a y, just slap a y prime on whenever you're taking the derivative. Okay, good luck with it.